Today we're doing surface area of pyramids and cones. Our goal is that we can find the surface area of pyramids and cones. Pyramid vocabulary. The height is the perpendicular distance from the base to the vertex. So you can see it right here going from the center down to straight down as if you dropped a string. And then we have the slant height is the height of a lateral face, a face that is not the base, and the variable L is used for the slant height. So the slant height is as if we were crawling up the pyramid, for example. Okay, or leaning a ladder up against it or something. All right, so the surface area of the pyramid. To find the surface area, we find the surface area the same way you would find it for the other shapes. You add up the areas of all the faces. Find the surface area of the following pyramids. So we're going to scroll this way. Okay, so we have this. It's a rectangular pyramid. Actually, it's a square pyramid because it is a square base, but with the 8x8 down at the bottom. So we just look at all of our faces. It looks like our triangular faces are all the same. So we have, let's see if I can get, yeah, there we go. Get rid of that green circle. Okay, so we've got the 8x8 base down at the bottom, and then we have 4 triangular faces. So we've got 1/2 of the 8x12. So the 8 bottom and 12 for the slant height of each triangle, and there's 4 of those. So we do our math there. We get 64 for the base, and we got 4 that are going to be 48. 8x12, and 1/2 of that is 48. Okay, so we do the math, and we get a surface area of that one of 256 feet squared. Okay, moving on to our next one. Actually, I'll go ahead and get rid of that. Okay, so we are given that the base of this triangular pyramid is 62 4/10 inches squared, and it has a slant height of 10 and a base of 12. Okay, so remember, base is the big B area is the area of the base. Okay, so we're given the area of the base is 62 4/10 inches squared, and then we have, it looks like all of our triangles that make up our pyramid are 10x12s. So we do 1/2 of that times 3. So we have 62 4/10 plus 3 times 60, giving us 62 4/10 plus 80, giving us 242 4/10 inches squared. Cones. What would the net of a cone look like? So if we unfolded a cone, it should look about like this. So we have our slant height would be here, our radius of our circle, our area of our circle is there, as we've been studying. So here, this is the lateral portion of our cone, right here, the blue. Okay. How do you find the circumference of a circle? Hopefully, we've done enough and you guys know enough to know that it is pi times diameter, or 2 pi times the radius. All right, so it isn't only one part of the portion rounded of this part, looking at this. So therefore, we use only one radius times pi. We multiply this by the slant height. We combine this with the area of the circle to get our cone surface area formula. Let me get rid of this. Okay, so here's our surface area of our cone formula. 2 pi RL, I'm sorry, pi RL, not 2 pi, pi RL plus pi R squared. So we're saying here this is only a radius to the circle, The slant height is the radius of the circle. Basic. Well, no. This right here is the radius. Not necessarily going to be the slant height. Okay, moving on. Here we go. So we're going to find the surface area of this particular cone. We've got 6.5 millimeters for our radius, and we've got a slant height of 21 millimeters. Okay, so again, we should always start, especially on something like this where the formula is so formulaic, for lack of a better word. So we've got our formula. We fill it in with what we know. We've got 3 and 1400ths for pi. We've got 6 and 5/10 for radius, and we've got our slant height of 21, and then we've got pi again, and our radius squared. We work out the math on those, we add them together, and there's our answer. So hopefully if you have any questions, you will write them down, bring them to class, and I will hope you enjoyed our lesson. I will see you next time.